What's up guys, it's Andy, BC Build. Sorry again about the shitty video using the forward facing thing on my tablet, which is a really bad camera. I just wanted to give a few tips on how to build a longer stroke liner. Everybody seems to want a longer stroke liner. And there's a few easy ways to do that. So I should have videotaped the whole thing before, but for a buddy, I actually took an old machine that I had retired, which was a gray wash shader, but had a cutback hole on it. And I cut a spring for him. I showed him how to cut the spring and set up a long stroke liner, which you guys have seen before. This is my retired gray wash shader. I retired this. I started using the Next Gen primarily. There's nothing special about this machine. There's really no magic behind it. But I'll show you one of the secrets. One, get a long armature bar. See how it's nice and long? There's really no gap between the spring saddle and the armature bar. The reason for that is, well, I'm not even talking about that point. Well, the fact that there's even less gap back here, it means the spring is going to have a little more tension. So you can use an 18 gauge spring. You don't have to use a 20. The size spring you use all depends on how fast you want it to go. For something like this that runs around 140, I recommend cutting your own 18 gauge spring so you can fit it correctly. The armature bar, this is a 1.65 armature bar. Try to use the longest one you have. Having the short gap in the back allows me to have the same tension as having a bigger gap in the 20. The reason why I'm having a smaller gap in an 18, and I'll show you in a second, it allows me to have a smaller front spring. A small 20 gauge front spring will be too stiff. Well, you could cut it thinner. It was just I do a one piece, and it was just easier to use an 18 gauge. But the trick to getting a long stroke liner and still having it quick, because you can have a liner that's a huge stroke, but usually they're going to run slow. You want your the front spring, you want it to sit as far back on the machine as possible, as far back on the armature bar. See where the screw is that screws it down? Most machines sit right about there. The farther back you have it, sitting as far back, you can see these two screws are damn near touching each other. This spring starts a lot farther back on the machine. It's the same spring you would use even if it started up here. The fact that the spring sits so far back, using a cutback setup where the binding post is behind the front coil, the spring doesn't reach nearly as far out this way. The difference that this makes, the spring sitting so far back, is you still have the same gap, same small gap, which is anywhere from a dime to a nickel, really all depending on the speed you want. Depends what spring. You can see the gap there. So that'll give you that speed. To get the speed, you have a small gap. But because the gap is set so far back opposed to here, if your gap was all the way out here, the contact screw in the front of the spring, your throw is only going to be as far as that gap. But because the gap is set so far back behind the front coil, the fulcrum effect, the farther you get away from the front spring and the gap right there, the farther away you get, the gap's going to increase. So by having the spring set so far back, you still have a small gap, which it'll keep it fast, but you notice the height between the actual coil and the armature bar here is a lot smaller than where the coil and the armature bar would meet up here. This gives you a longer stroke. One piece of 18 gauge spring. Most machines that are a traditional setup, they'll run this speed, but they have a much smaller stroke. This, I'm sorry, I was just fiddling with it, so it probably doesn't sound that great, but there's an extremely long stroke on it. It's about 3.5–4 millimeter stroke. And that's 138 and 53 duty. And the reason I went with an 18 gauge on this was just so I could cut a shorter front spring, shorter, I mean shorter, as in from the screw that screws it down into the armature bar to where it meets on the contact screw. The shorter it is, means it's going to be farther away from this, meaning a bigger gap. Sorry, I'm tired, it's hard to explain. But you want the spring to start as far back as you can. That'll give you the same air gap, between the contact screw and the spring, but it's so far from where actually the needle is actually put onto the nipple, the binding or the needle bar up here, that this gap is going to be far bigger than what it is back here. That's how you're getting the speed from the small gap, but you're getting the long stroke because the needle's actually put on so far out here. Most conventional liners, the spring comes right out to here, so you're only getting a small dime to most nickel gap, 2 to 2.5 millimeters. When you have a setback and a cutback like that, and you have a long armature bar that comes out, that's how you get this long, 3 to 4 millimeter stroke. Might I add, that's only at 5.5 volts. I'm pulling the clip cord out. That's also the other advantage of using the 18 gauge spring. Because I'm using an 18 gauge spring and I cut it thin, I don't know if you can see that, it's actually thin this way. It has a little more flex in it. And that little extra added flex, when this comes up and rebounds, it'll flex. And it'll actually, not only the magnet, but the flex from that spring, wanting the spring back, will actually slam it back down, which will give it a little extra power. This will in turn raise the duty cycle sometimes. It's all really give and take. You got to fuck around and fiddle with it to get it into even range. But because it's a thinner and a little more flexible spring, it has that little rebound, which will actually slap it back down. If your spring is too stiff, you're not going to have the power because it's basically just being abruptly halted. It's like bam and then stop and then goes. This 18 gauge spring in the front, or at least a smoothly flexing spring, that's why you want to thumb roll them. Which I mean thumb rolls, you want to curve them instead of one bend right here, just one little crease and then straight. You don't want to do that. You want to thumb roll them. Basically have an even bend the whole way. That'll give you an even flex, or an even cycle for the most part. When this the binding post comes back up, it's actually being abruptly halted. This spring is slamming into the contact post. When you have a rolled front spring, it's a lot smoother of a stop. When you just have a flat spring, it just kind of bangs. And if you watch it in slow motion, when it hits, it'll actually reverb a little bit. It'll go up, down, and then go back down. When it has thumb rolled, basically an even curve all the way in the front spring, and do the same in the back. You want the back spring rolled too. That's why I do a one piece. I roll it on I actually use a screwdriver. Just hold it over and roll it back and forth until it's what I want. Given you have to adjust it when it's on there a little bit. But a little more flexible spring gives it a little more wallop. I plan to use this on, like 9 rounds and shit, 7 to 9s. Oof, I have to break my fucking tablet. I took a picture. I thought I ended it. So that's it, guys. And if you want to make a really powerful or a really fast fucking liner, instead of using an 18 gauge spring, use a 20 gauge spring. It'll have a lot more tension in the back because there's no gap. If you want something that runs 160 cycles per second, set it up this way. The big long armature bar will give enough mass for the coils to pull down on. The more mass there is, the more the coils have to pull on. There's more strength. It's lightened in the front. I have holes drilled in it too. Because of the rear spring is, there's no gap, there's going to be a lot more tension, so it's going to rebound a lot quicker. And because it's going to be a lot stiffer, you're going to have a little more flex on that 20 gauge spring if that's what you have set up. So if you want something that runs insanely fast, set it up like this with a 20 gauge. If you want something that runs average, set it up, around the 140 range, what it's set at, set it with an 18. You can do it with a 20, you just got to have a little more flex, and you won't get as much stroke, and probably be around a 3 millimeter stroke opposed to this, which is almost 4. Sorry, guys. All depends what you're looking for. And if you want something that runs slower, around in the 130 range, use like a 17 gauge spring in the back. You know, it really all depends on the tension. It all depends on the angle of the spring deck. This is a little angled. It really all depends. You know, the size of the coils. Well, not the size of the coils, the size of the capacitor. I just wanted to point this out. The size of the coils, the actual layers, the wraps, whatever you want to call it, 10 wraps, 6 wrap, 12 wrap, that does not affect the speed. That will only affect the power and the amount of electrical energy you can create with them. Smaller coils, 8 wrap coils would run the exact, if these were 8 wraps, it would run the same speed as it would 10 wraps. The voltage would be a little different. The difference between 8 and 10 wraps is 8 wraps, it takes less voltage to get a magnetic current. But when you have 10 wraps, you're actually, your peak magnetic current will be bigger. You're able to create more in the long run, but it takes more voltage. But to get the same amount of power out of an 8 wrap opposed to these 10s would take less voltage. But the 8s overall won't be able to gain enough power, as much power as a 10 would. The 10 will take more power to run. The 8 will run on less voltage, but won't have that overall peak power that a 10 does. What creates the speed is the tension in the springs, the size of the armature bar, the gap between the armature bar and the spring deck, and then the capacitor, and the air gap and all the obvious shit. But the actual wraps on the coils is not going to affect the speed. So when people, say, what should I use for a liner or shader? Only use 8 wraps on a liner, only use 10 wraps on a shader. Honestly, it really doesn't matter. Most of my shaders have 8 wraps. Most of my liners have 8 wraps. 8 wraps can create a big enough magnetic field to push anything that I use. I don't really use anything past a 15 mag. The only reason you need a 10 wrap coil is if they're, not so great coils, or you're pushing something, 25 to 50 mag. Yes, then use a fucking 10 wrap. But as long as you have a set of quality coils that aren't bobbins, that have capped on tape, real magnetic wire, the SX copper, you don't need anything bigger than 8 wraps. Unless you're pushing something big or those shitty coils. If they're wrapped on bobbins, then get 10 wrap ones. And they'll probably be advertised as 10, but they're really 8. That's why I buy from reputable dealers. These were some of the first coils I ever wrapped, and I really didn't know much about coil science at that point. That's why these are 10 wrap. This was originally a shader. They would have done the same job with 8 wraps, just on a lower voltage, but I'm going to change them. The only thing, they're capped on tape. I glued the washers on. The only thing I'm going to change about these coils is I'm going to take 2 wraps off. I'm just going to cut the wires, unravel 2 layers of it, and put them to an 8 just so it runs on a little lower voltage. This right now, as you saw, it was running on 5.5. It would run loaded on 7. I wanted to get it to run around 6.5 loaded, and that's pushing us 5 or 7 or 9. Hopefully that helped you guys. Probably not. I'm kind of rambling. It's all, how to set up a tattoo machine is all subjective on the frame and the parts you have. And you're not just going to pick one good part that's going to make it a good machine. You can't just say, I'm going to use 20 gauge springs and then that's going to create a good liner. You need a complete good setup. The wraps on the coils don't make a difference unless you're pushing Hughes needles. So don't worry about the wraps on the coils. Stick with an 8. 8 is an overall good size, and most beginners that need to watch these videos aren't pushing these gigantic needles. I've been doing this for a while now, and I still don't push gigantic needles. Really, to create a good liner, it's an overall package. You want the binding post to be at least even with the front coil or behind it. You want a lighter armature bar. You want the stiffer, shorter springs. You want the spring to start farther back. You want a 33 UF capacitor. This is a 47, but it was a shader, and I'm just not changing it. You could get more speed out of that. A 33 will have less power, so it won't hit as hard, but it'll run faster. So to create a good liner, it's really a combination of all the parts. There's not just one part. It depends on the geometry of the frame. Some frames are really just not meant to be liners. Like this wasn't. These are just decorative holes in the side. I was able to put the binding post back. But the binding post sitting way out here, there's no way I could have that spring sitting all the way back here. Reverse angle liners they work, but they're the least effective way to build a liner. Having the contact screw sit backwards like this, when you want to adjust the gap, when your contact screw sits backwards and you're adjusting the gap, it's not only going down, but it's going back. So it's not like you're just adjusting how big the gap is. when you turn that screw, it's actually changing where it's hitting on the spring. And that makes it extremely difficult to fucking adjust the machine. That's why these reverse angle liners are basically just people that are using shader frames to build liners. And it is possible you can get them to run amazingly well. It's just, I think it's a cop-out to me. If you want to build a good liner, use a good liner frame, or like this. I used one of the holes. I just adapted the shader frame. Don't stick it in the shader hole and have your fucking contact screw sitting backwards. Take the fucking time. And if you can't do that, get a piece of fucking copper. You know, drill a hole, you know, a little length, 1-inch thing of copper. You know, bolt it to here and have it come back, and then bolt the binding post onto that. Turn it into a cutback. I did that with like 6 of my Unimax machines. Just do the right thing and you're going to get a good machine. It's a collective of all good components and knowing how to fucking tune a Tactine machine. Alright, I'm going to bed. It is 1:30 in the morning. I am tired as shit. Hopefully that helped. Probably not.